Och den här funkar? Ja. Jajamän. So probably gonna speak English. Is there any English speaking people in here? Okay, perfect. So welcome to the Fusion 360 presentation. My name is Lars Nyström. I am based in Stockholm. For those of you who know Swedish and talk to me, you're going to realize quite quick I'm not from Stockholm. I'm from the northern part of Sweden. But I've lived in Stockholm for 8 years approximately. I've been in this business for 12 years now. I started as a consultant for a Autodesk partner. And then I worked as an actual partner then for a couple of years, and now since 3 years I work at Autodesk. I spend my days with visiting customers, basically. I visit customers and I try to understand what their daily issues and pains are, and then I try to help them to resolve it, of course, with Autodesk products. But I try to help them be more efficient with the tools that we have. And my sole core solution that I've been working with for all of these years is Autodesk Inventor. It's our core main product that we use, but now for a couple of years I've also been spending a lot of time in Fusion 360. So that's what I do for work. My personal side is I'm see and I realize I'm not a high-end maker as some people here, but I see myself a bit as a maker. I love creating stuff. I have a couple of mills and I have a couple of 3D printers at home. But mainly when I don't do that, I skydive. I do that not professionally because then you get paid for it, but I do it as close to professional as I can. I jump all summers, almost all winters, and then I compete. That's what I do. So it's a quite simple explanation of my what I spend my time doing. So before I start rambling about what Fusion 360 is and what it can do and show you some tips and tricks, I want to get a feel for you guys, your experience with Fusion 360. So just with a quick handwriting, how many in here already uses Fusion 360 today? So quite a lot of you. All right, so I'm going to try to fit in the wide spectrum of the users. So I'm going to start by positioning and show what Fusion 360 is about, where it comes from and why we created it, and the initiatives we have from Autodesk around this. And then I'm going to, as further we go from this hour, I'm going to go deeper and deeper into Fusion, and at the end I'm going to show as much tips and tricks as I can to hopefully give value to all of you in here. But first of all, where is Fusion 360 originated from? I mean, we have AutoCAD, we have Inventor, we have a lot of solutions at Autodesk that many of you already know. But Fusion 360 is quite a new solution on the market. I mean, it's 6 years in the making from when it was first launched. It was actually launched as an add-in to Inventor to do freeform or to do direct modeling. And then it was really appreciated from the users and it became their own certain product. And from that, we asked our users, our maker community, like, what would you like to see in a 3D CAD software if it was made and created today? And Fusion 360 is basically the result of that question, that survey that we did. And people said that they wanted I'm going to come to that. But first, we're just going to look at some quick history where CAD or where product development comes from. So all of the CAD solutions that's been out there has been created from a platform shift. I mean, we started with the actual mainframe. We had something that we can design on. It moved on to, I mean, a lot of you can relate from the AutoCAD beginning on the Windows machines. Pro Engineer was the first parametrical solution that was out there. And SolidWorks was the first on Windows NT. So it's been all driven from a platform shift. Something that happened in the tools that we have has been driving the CAD solutions. And before we move into the shifting for the platform right now. We have to think of how we are consuming, how we want products to work today. I mean, even if we buy a phone or if we buy something for our home, most of these things are connected because there is some value in it. I mean, if we have tethers, for example, it's a Swedish brand to make Internet of Things of your home appliances. I mean, if you have a electrical socket and you plug a lamp into it, you can still steer it with your phone. I mean, it's a connected solution. Same thing as a product as a service, and this will, I mean, for people who've been going to a lot of seminars, this must be the most used example for a product as a service ever. It's the Power by the Hour from Bentley, and I mean, we can use something that's a little more relatable to what we use every day. Netflix is also a product as a service. I mean, we pay for it as we go. If I don't like it, I stop paying for it and I get rid of it. Same thing for Fusion 360. It's I mean, if you don't, a hobbyist or a maker or a startup get it for free anyways. But for those of you who actually pay for it, if you don't like it, you just stop it as subscription. And it's quite interesting because this tells us that Autodesk, we have to change the way we deliver our solutions. We have to make sure that our users really like the solution, because otherwise they can quit it that day or that month and then they can move on to something else. It's really important for us from our side to make sure that the users are actually enjoying the software. Also, manufacturing methods are changing. I mean, with 3D printing, not just for plastics or composites, it's also for 3D printing metals. This is changing the tools that we're using. I mean, if we can free up and do anything we want, then the design tool that we use has to change as well, so we can cope with these demands. But the biggest thing that made Fusion what it is today is the platform shift to cloud. I mean, it is a cloud-enabled, it is a cloud product. It's not 100% cloud product as some of our competitors, but it uses the cloud for the good stuff. And this is what made Fusion what it is today. And if you move into and look at some quick examples, I promise you, it's going to just give me a couple of more PowerPoint slides, and the rest is going to be in Fusion. But this is an example of what Fusion can do in general. I mean, it's a 3D modeler, parametric, direct, and freeform, all in one. We can do renderings, we can do CAM preparations, we can do all of that. It's a cloud-enabled product, meaning that everything that we save is going to be uploaded to the cloud, to a user-based interface. We can access our files wherever we want. You can see some examples of freeform modeling, also some parametrical ones where we add plastic details, so we can add those parts as well. It's also a really good direct edit tool, meaning if you import something from a different provider or you have a file and you need to change it, it's also really powerful in that. Also, we have 2D documentation, so we can do drafting. We have simulation as well, and for those of you who are used to simulation from a CAD world, it's the Nastran solver. It's a well-known worldwide solver that we acquired a couple of years back, meaning we have linear, non-linear, soon we are moving into a CFD simulation as well, and we have vibration, heat, and we have a ton of different ways of simulating our designs. And as we can see, we also have an integrated CAM solution from 2.5 axis up to 5 axis simultaneously CAM preparation. And all of this is inside of Fusion, and it is a really, really powerful solution. I mean, we're going to have the option to do whatever we want in it. And by the way, I like when it's integration or interaction, so please ask questions during this. I'm encouraged that. It's just, or if you don't think I'm right, just stop and tell me I'm wrong. It's fine. So that's Fusion in a glance. I'm not going to have time to show you everything because it is a lot. We have everything from sheet metal to mesh editing. We have a connection to ECAD or a newly acquired Eagle electrical software. So there is a lot of stuff in there. But I'm I'm going to do this. Before I start talking about what Fusion 360 does, I'm going to back off to the cloud part, and I'm going to start by discussing the Fusion team part of Fusion 360. And Fusion team is just the file store, or it's not fair to call it a PDM system, but it's a online file store for Fusion. So all files I save, it's going to automatically be uploaded to a project, and this is Fusion team. But as I said, we pause Fusion 360 for 5 minutes, and then I just explain what this can do to anyone maybe not even using CAD, just want to look at 3D files. So this is just a website, and so I go into mine, and I go to the top right corner, and then I start from this. So I can start by creating a hub. Inside a hub, I can have a project, and inside a project, I have files and folders. I can have different hubs for different things, for different customers, or different projects, or whatever it could be. So I can create a ton of those. Now I'm inside of mine called Skizografen. For those of you who grew up in Sweden and are awake, Skizografen is the drafting machine in Dr. Snuggles. I think in English it's called the Badgergraph, but whatever. So inside of my Skizografen hub, I have my projects. I have a ton of them. I just show you the ones that are owned by me. Then I have some projects that is shared by me, and some that are archived, and so forth. But these are the projects that I have. It's just a good way of separating from other projects. And inside of, for example, the one that I call Fusion Team, I can have different users. I can add more people into this. I have Rickard, a colleague, as an editor. I have Maria, she's a viewer, so she can only consume information in this hub, in this project. So she can't delete or change anything, which can be good if you're just a reviewer. And if I look at the files in here, these are a mixture of files. It's everything from IPT parts from Inventor, SolidWorks, step files, STLs, FBX. There's 65 plus formats that you can import to this and get a viewable. Meaning, if you have a file on your computer and you want to see what it actually is, and you don't have a CAD software, or you don't want to import it into your CAD software, you can just drag it into here, and then you get a viewable. And anyone can do that. Anyone with an Autodesk account, and the account is free, and then you start with this viewable. It's really, really powerful. And I took an example. I shielded a bit. I downloaded a step file from GradCAD. I just imported in here. I took a Lego, not just because it's fun. This Lego contains a ton of parts, and this showcases the actual strength from what we call internally the large model viewer, or the Autodesk viewer, because it's made to be able to showcase and view very large files. I mean, we have everything from a 3D plant to buildings to stadiums. We have really big models in this. But if I take and I just look at this, and also remember, this is just in the browser. It's nothing installed. It's HTML file, GL, so nothing needs to be installed. And I can just either click and drag, and I get a viewable of this, or I can use, if it's a touch screen, I can use that as well, just to navigate. Meaning, if you have a phone or a tablet or whatever, you can still access this. And if I take one of the standard functions and just explode it apart, we can see it contains files, it contains a lot of stuff. And it's still really, really easy to navigate. That's just, I know I'm rambling, but it's good. You also have measure commands, so you can get measurements. I mean, if you should send it to someone, I mean, if you are in a professional business and you send a file or a PDF to someone, they're going to be, okay, good. What's this measurement? You forgot it. And then you have to go in, you have to take that measurement, and you have to email it back. It's better than if that person can take that and measure by themselves. Or print it, or make a section, slice it to interrogate this model even further. So we have a lot of tools for this. Also, the two most important parts before I stop talking about this, move on to Fusion, is the collaborative part. I mean, if I want to communicate something to a customer, or a partner, or a colleague, or whoever, I I usually take a screenshot and I add some text and an error or something, and then I send it by email, and then it's an email thread. And that's, I mean, it works, but it's not perfect, because if the design changes, I have to make sure that that person see the most current up-to-date PDF or printed stuff, and I don't have control over that. I mean, I like control, so if I make a change to this, it's going to update whoever has it. So if I want to communicate something now and just do a quick redlining, I'm going to do a markup. I draw something, I add some text, I save it. I can see that the person who actually made that comment is going to show up because I'm logged in with my user. So Lars made this comment, he made this. So if I then go back and click on it from a other user, for example, it's going to show me that markup. Good. Then we can reply, and then we can have that email thread, but we have it on the actual model. Good. And then if I want to share this, of course, I have to show the sharing. I just say, okay, open this for sharing, copy that link, send it to whoever. Should the person be able to download the original file to his computer? No. Should this be a password? Yes, because we're going to have some security logs. And then if this changes or I remove it or it's end of life or whatever, then I can say stop sharing this link, and all the persons who have them see it. Powerful, because then I can make sure that everyone see the most up-to-date and current version. All right, this is Fusion 360. It's still installed on my local computer, meaning if I now stop internet, I have no internet connection, playing or wherever, I go to Germany and have good connection, I can still work offline, and it's fine, because as soon as I get online again, everything that I made, everything that I saved is going to be uploaded. And it's not a file. I know I'm getting technical with this, but it's not actually a file that we save on a computer. The file or the thing that we're working with is actually a database thing, meaning because it includes CAM preparation, simulation, the CAD file, linked stuff. So it's a database. And it's encrypted, so if my computer gets stolen, they won't find a Fusion 360 file on my computer, and then they can start doing stuff. They will just see nothing that they can actually use, which make it the security part of it really good. Anyways, on the left side here, if I look at that, it's
regarding the offline, what happens once you go online and let's suppose that you and your friend has made alterations on the same part?
It's going to be a new version for every time you upload it.
Okay, cool.
So you're going to have from 1 till 200 versions. It's going to be a version. So if your friend has made something that you don't approve of, you can promote your version to rule his version and become the most current one. So it's ways to handle that. The data panel on the left is quite small, but the data panel is the same one that we looked on the web browser. I see the same projects. I see Fusion Team. I see the snow speeder here. And so I have the same in Fusion as I have on the web platform. There is also ways to automatically download everything, so I have it locally. I'll make a note of this because I could so I don't ramble on too much. Okay, so Fusion 360, here it is. If I start by showing some of the real benefits of actually having Fusion compared to a traditional CAD system, because we have to start there. Why did we do this? If we do something from the ground up and we do it completely new, where is the difference? Why would I care? I mean, I have Inventor, I have SolidWorks, I have Creo or whatever. Why would I care about this? So I have my extremely advanced assembly here, and this is an example of something very easy. We have models. At the left-hand side, we have the model tree, where we can create the structure, and at the top we have tabs where you can jump between different files, and at the top here we have the tools. All right. So I'm going to start by assembling these. And I say this box, the middle of this box, because if I hover over a surface, it's going to give me automatically some control points. which is good. So the middle is always there. I don't have to draw a sketch on it or create a lot of planes. I can take the middle of that, it's going to go to the middle of that, and it's going to show me that constraint. It's going to show me an animation how this actually is mounted. So okay, that's good. The next one, I'm going to do the same thing, equally advanced. I'm going to say that this middle edge is going to go to that middle edge, but instead of being rigid, we're going to make this as a hinge. And Fusion works the other way around from a standard or a traditional CAD system, because then you are locking the degrees of freedom all the time. Here you lock everything at once, and then you release that degree of freedom that you want. So everything is going to be locked until you say otherwise. Meaning that now this is instead a hinge, and I can work with that. Cool. This is something that could take an hour to explain in a good way, but Fusion always remembers where the position is. It always wants control over where the position is. So I can move it around freely, but now I get two choices. Do you want to capture this new position and make this position the new standard, or do you want to revert it from where it was the past default? So I can move it around and say, okay, revert it. Okay, I can move it there and say, capture this position, and next time I revert it, that's going to be the new position. It doesn't say that you can move it around and play around with it, but as soon as you want to lock it, you want to know, because that position is going to be a lock in the history. It's not a tree anymore, history bar, timeline, call it. So now if I want to remove that, I can just delete it, and then we can revert back to the original position. I mean, there is some value to this. I'm going to explain it. I mean, it looks like an extra step now, but it's going to be better. Anyways, down to the point. That's nothing super special. But when I choose fillet, I click F on my keyboard to get a fillet, or I can click S, and then I can type fillet, and then it's going to show me the different two. So it's a quick way of getting in hand what you have, the tools that you need. Anyways, I take fillet, I select everything, and then I give this is whatever 3.163 millimeters fillet. And now everyone that's like that know a traditional CAD system, if I now click OK, it's gonna scream at me, because it's gonna say this doesn't work because the edge that I clicked, the two corners, doesn't really exist anymore. So the reference is gone, so this shouldn't be working. But that because of everything that we do in Fusion 360 is timeline entities. So at that time, when I clicked that edge existed. So it doesn't matter on what you do after this. It's still gonna be, it's still gonna work. It's still gonna be that that kinematic is still gonna work. Same thing for this one, meaning that it gives us a little more freedom. It doesn't makes us worry so much of how we design that tree. I mean, how did we start it? How did we import it? How it gives us more freedom to just do what we need. That's good. Everyone with me on that one? Anyone object? No? All right. It's fine. It's good if you object. So that's one example. And if you continue, if you draw something from the beginning, let's say we're going to do, I showed this to someone out in the fair, but let's say we're going to do a box, a simple box with a structure. It's going to be a bottom part, and it's going to be a top part, and it's going to be in a hinge. It's going to be no more advanced than that. So I start from the beginning. Let's say I'm going to draw a 2D rectangle on this. It asks me where do you want to draw it. It's going to be on the middle surface. It's going to have a specific distance. I can type it in, but I don't have the energy or time for that. So I just take this, rectangle, and I right-click on it. And that right-click is going to give me an option. It's going to say press pull. Press pull is kind of the magic function that knows what I want. So if I say press pull, it's going to change from press pull to extrude, because it thought that if you clicked on an open sketch, the only thing that you really can do here is an extrude or a revolve, but it gave me extrude. So, and then I give this a height, and I click OK. If I continue, if I then say press pull and I click on an edge, it say, okay, you're probably gonna want fillet because this is an edge. You could have done a chamfer, but this is the most common one. If you want a chamfer, you right click, it's gonna show me fillet and chamfer. So it's contextual. It's gonna remove a lot of stuff that I can't do with that edge just to give me a simpler interface. We continue with a shell because we're going to make a shell of this because this is a box. It's 2 millimeters thick. All right. Everything that I do is parametric right now. We don't see it because it's just that happen in the background. But I want to show this. So all my models, everything that I do, extrude, the shell, all of these are giving me parameters. So I can always go back into this list and say, this should be a 3 millimeter thickness instead, and then it's going to go in and change that thickness to 3 millimeters instead. So you can create, and you can create this to become quite smart. Nonetheless, I continue. I'm going to create a lid, so I'm just going to sketch a new sketch on top of this, and just going to give this an extrude for a thickness. This shouldn't join the thing that I just draw on. It should become a new body, because otherwise it just becomes a part of that body. I want these two to be separate so I can then constrain them later on. And Fusion always starts with one body, and bodies are like work bodies. We should see them as something that we use when we're modeling. If I want a body to become a component, then I have to tell them that. These two should actually be components. The first one is called bottom, and these are the top. The bottom is completely rounded. I don't want something to be completely free. I want to be able to constrain something to something that's fixed in the space. So this one is completely fixed. This one is completely loose. And this is also an issue when we do top-down design. We're designing something, and after a while, we are creating the components because we don't know exactly how this is going to work and how it's going to look. So after a while, we know, okay, this should be a component, this should be a component. And then the problem is that it doesn't know where it fits, where it belongs. So that's why we have a function that's called as-built joint. It does the same thing as a normal joint, but I know the joint word is weird, but it's called the joint. So that one has a relationship to this one, and it's revolute around that edge. So then if I design it myself, it's good. I'll also think of if I'm importing something, a step file or something from a different solution, I can make it move as it should, but I don't have to spend a lot of time doing that because as-built joint works. It looks how it is placed off, and then just add a constraint where it lays. So that's good. A new part on this. We're going to create something additional on this. We're going to create a different structure. Then I can create a new, take a standard primitive, because you can do that as well. I'll just add a cylinder to the top. It shouldn't be joined to that part. It should be a new component, all right? And that component should also be as-built to the top, and it should be a rigid one. So I can quickly create something that moves and handles the way I thought it would. And I can also change the actual structure. So if this component, the tube, should be part of the top, then I can just add the tube to the top. It created a subassembly, and it still remains with all of the constraints that it should have. It doesn't remove just because we change the structure. So that's good. Any questions so far? All right, I'll be here later if you want to ask questions. I'll continue. So is okay, I know I say an open question to a lot of people, but the speed is do you want more in-depth, or should I continue this kind of level? All right. And here, yes, I take it. So this is one part. We are in the modeling space. And models, we can handle models in different ways. This is something that we draw from the beginning, but it could also be something that we imported. So I have one. I know I stole this from Thingiverse. And some of you in here designed this. Sorry, I know I didn't design it, but the thing is that when I show this is purple, meaning this is a STL file. This is a meshed file that I imported. And a meshed file, in simple words, we don't are familiar with this file format. It sucks. It's good for 3D printers because it makes facets of it, and that's how 3D printers work. Not with the new 3MF format, but whatever. It's a good format because it's light. It sucks because it makes facets, like small square faces of something that should be. I mean, this should be round from the beginning, but the quality is based off this from there straight. That's what it does. This format is growing. It's been growing rapidly, especially with 3D printing. Hype is going so big, so we have a lot of step files, STL files. When I'm going with this, if I want to change this, I want to add something, I found something that I want to change and change the size, or I want to edit the hole or whatever, I need to be able to do this. And you have two ways. Either you can go into Mesh Mixer, it's a mesh-based editor, and then you can do that, that's good. Or if you want to incorporate this to some Fusion design, you can do that as well. You first have to convert it. And standard, when you import something to Fusion, it imports as a non-history model, meaning that the timeline is gone because we don't have a timeline, meaning everything we do don't get remembered. It's going to change the model, but it's not going to remember. We can't go back in that history tree or in that timeline. Keep that in mind. So what I'm going to do now, I'm going to convert that mesh model into a D-rep, boundary representation. And if this is order tight, meaning if it has the potential to become solid, it's going to convert it and make it solid. If there is maybe a surface that's broken, it's going to tell me, okay, I couldn't make this into a solid model. I made this into a surface model. Maybe that's not important. Anyways, one of the magic things of doing this, we see that the top surface is divided into a ton of subdivided surface. So if I click on one and I click delete on my keyboard, it's going to remove all of those and sew it into one surface, because it feels that this is the boundary, and all of these, if you want to delete this, you probably want to delete this and this and this and this and this, and then it makes it one plain surface. If it would have been a little crooked, of course, it wouldn't have deleted it. But if it's completely plain, it's gonna solve that for me, and that's quite powerful if you are doing these type of edits, because if you remove these many surfaces, it's going to become much lighter, and that's something that you can use. And now this is a solid model, so if I want to make a hole in this, or I want to make a change, I can just continue working with it, and it's going to behave as a solid model because it's a solid model. Then I can make changes, and I can save it out to an STL again, and then I can 3D print it. So I made some value changes to this. But it's not always as easy to edit an imported STL file, I know, but with this method you can make it to, you can actually change that. So yes, if I move to this one, this is also, I mean, the story from this one is quite simple. It's a personal project we have in our living room back home. We have a big coffin, like a nice old coffin, super old, but we can't really use the space inside of it, I think, because when we're going to open it, it's just a hinge. And if you have stuff on it, you have to remove it to be able to open it and lift out the stuff that's inside. This is a coffee table. But what I did then, I made a suggestion that you could do like a change. I mean, if I can just hammer away the hinge, I can make a different kinematics so it works. I couldn't do this, but it works, but I couldn't change it. But this is also an example of what you can do when it's when the motion is the most important one. I don't have added any fasteners or anything in this because I don't need it to. I only needed to know the actual length of these. These are made with sketches, and these are made with traditional ways of handling this. Yes. Another part from this side that's quite important. I'm going to create a new, forgot to mention that in the beginning. I'm going to make a new thing here. I'm going to make a box again because those are quite advanced. So remember that we have history. We can always go back to that sketch. We can add dimensions, we can add radiuses, we can do whatever we want with it because it's just a sketch. Then we can go back to the actual extrude, the feature that gives this height. That's the traditional way. But let's say I'm going to make this smaller or bigger in any ways. If I right click and say press pull, remember that press pull was the magic function that changes depending on what you're clicking on. If I click press pull and I change this now, and I go back, it actually changed the actual extrude, and it didn't add an offset. Meaning if I now go back to that extrude, it changed that value and it didn't add anything because it felt that, all right, I can do the same thing on the side. If I now add that inside with an offset command, you see it doesn't add anything after that extrude in the timeline, meaning it actually changed the sketch. So if I do a direct model function on something that's modeled in Fusion, it's going to change that parameter. Meaning if it didn't have that function, it would have added an offset feature after that. And then after a while, this history tree or this timeline is going to be really, really long, and the model is going to be heavy. So this is a way to much more smooth. But if it is a dimension there, as I made now, I went back to the sketch, I added a dimension, then I do the same thing. I say press pull. It knows that this is something that needs a new offset because we can change, we can change that fixed dimension because we probably think that's important. That's why we added that dimension. And then it adds an offset value. All right. An ID here. So I'm going to go back here for just a second, and I'm going to show you a different project I made. This is 3 years ago, I think, so I don't have this anymore. This is beyond my timeline now. It's in some box somewhere. But at this time, at the moment, it was very important to me because from the issue was, or the thing was, I found a way to add Mega Man 2 to my phone, to my iPhone. At that time, there was no emulators. It wasn't super legal, maybe, but I found a way to add it to my phone, and it was good because then I can play the games that I like on my own plane. So that was the first mission. I got it to work. Then I wanted to upgrade, so I bought a controller that I knew worked with the iPhone for other games. I actually got it to work with that emulator as well, so I was super happy. The problem with this is, like, I mean, if I have it on the plane, I had to position the phone and then have the controller, and it wasn't super clear. And because this isn't an out-of-the-shelf solution, I had to design a mount for this. So I can just put my phone on it and it worked. So what I had was I had my controller, and the only thing that I had at home that was a scanning device was a camera. So I'm going to use photogrammetry to scan this and then use that as retrofitting, or I'm going to use it as a model in Fusion so I can model around it. Because, I mean, I couldn't really, in a simple way, remodel that controller. I couldn't find it on GrabCAD. I had to start from somewhere. So I created a really simple photo studio, and I know it's a sharp direct light, but it didn't matter. But it's just paper, a camera, and then I hoisted it up into the air. I took 159 images just from every angle. I mean, that's the beauty of photogrammetry. I can take, it doesn't have to be in a certain order. I zoomed in on details that I know I wanted more detail. So it became around 160 files. And then I used Recap Photo to create that mesh model. And it is a mesh model. Of course, it brings the texture. You can see it's some bumps on it because of it was completely matte black. So I took a a whiteboard pen, and I just added some dots, so I had some references, because that's how photogrammetry works. It needs 3 points between every picture to be able to connect them together. But the model actually, I made 3 tries. The first one really didn't work because I didn't have the points, but the third one worked beautifully, and it's a good enough mesh for me to continue work with. So I took that and I imported it into Fusion, and it imports as a quad model. It doesn't matter what it is; it's imported. Then I downloaded the iPhone, because I didn't want to remodel that, because there is a gazillion iPhone models already drawn up perfectly good. So I used that from GrabCAD again. GrabCAD is good, a lot of free models. And then I positioned it. So I had a controller and I had the phone in real life, and I positioned it. Okay, this is the angle that I want. And then I positioned it, same thing in CAD. So I had, this is where I want it. And then I started to design the actual mount around this. Try to figure out this. There is a couple of iterations in between. I had one where it was completely around the entire model. But I found that this worked pretty good, because it connects into the charging slot. So I printed it, of course, and it turned out great. It worked. It was the first fit was a click fit, and it was just sliced the bottom, the other side of that model is sliced from the imported mesh. So meaning, if I go back to Fusion now, I look at that mount, and I hide this, I hide the phone, and I hide the mount. I used the lightning connector, so I just positioned it where I wanted it, and then I used that to combine it into remove the controller. So that's how it looks. So you can see it's sliced from the importer model. That lightning connector is positioned just from a visual reference to that model. It's made parametrically as well. So I'm going to close this down. I'm going to show you another example that I made. I'm going to steal some credit from Daniel Marie. He is around here. So where is it? Our stuff, OpenRC. A lot of you have seen the OpenRC model, and it's, I mean, it's brilliant. And I wanted to make a change to this, because it's a little too big for my backpack, and I wanted a small model that I could just bring in just for fun. So I took Daniel Nurre's model and I scaled it down to half the size. And then I started to make changes because I wanted a smaller model. And this is the result. I draw up dummies of all the components of the battery, the PCB board, the engine, and the rear hub, and so on. These are all from the car that I had. I just bought one for 50 bucks, and then I slaughter it for parts. So all parts and all screws and everything is from that model, and everything is half the size. And what I want to show with this wasn't to brag that I stole the design that was great and just scaled it down. It was that there is a function that probably that not that many Fusion users know about, and it's called a base feature. Is anyone here using base feature? Awesome. So if we have this is quite, I mean, I have a long history tree here. I also made it shorter because I grouped the first gazillion parts. But I have a history tree. Everything is based off a sketch. Everything is based off a parameter, a feature, or something that takes time to calculate. If we play with the idea that I'm going to make a new iteration, a new design of the rear wing. Doesn't really matter what we do, but we're going to make a new a change of this. So I want to combine that I still have the history in my tree here, because I can go back. I know I'm going back and forth, but if I go to this one, we see we have a history. I can go and say, okay, I don't want to capture design history anymore. Remove all of that. Remove it so I can still go in here and I can make changes, I can do direct edit, I can model, but I don't have any history. I can do that, but now I just killed the entire history tree of this part. So don't do that if you don't want to remove the history. You can go back. I can say go back and capture design history, but then it starts from it treats this as it's imported again. So if you have removed everything, and this is a really good way of purging the history. I mean, imagine you design for a couple of weeks on something and it's so heavy, Fusion can't handle it. It happens. We know performance is a part. We are working on that. But this could be a way of just purging the history, getting back, and then getting a model you can actually work with. Sure, you have to redo some parts. It will remain the constraint. The joints will still be there, and some parts it's still gonna figure out. But just as a warning. Anyways, just to confuse you guys even more, I have the history. I want to keep the history, but not when I fidgeting around with the new iteration of the rear wing. So I'm gonna go to this rear wing. I'm gonna say on the body, that body, I'm gonna copy it, just right click copy. And then I'm gonna say, I wanna create something new, not a new part, not a new body. I just wanna create a new base feature. So what happens then is I get a new base feature in my timeline. It says finish base feature, so it shows me I'm a different mode. Meaning I'm now in here, I'm gonna say paste. It's gonna paste this new rear wing, but it's not gonna capture any history as long as I'm inside of this base feature. So I can do whatever I want. I can delete, I can add sketches, I can do whatever I want, but it's not gonna be recorded. It's gonna change the model, of course, but it's not gonna be recorded in the history. So if I go in here and we do something simple, we remove stuff. I just do a window select of those surfaces. I click delete on my keyboard. It's really good at sewing things together. This is the direct modeling part I was talking about. It's really competent in handling imported or non-history files. So we made a change. We can do something more, because otherwise, if I didn't have a base feature, it's going to show me delete, 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 move, delete, and show me all of the history. Also, another feature that's quite good is the edit face. So if I choose edit face, I click on that face, it's going to temporarily convert that face into a freeform face. I know for those of you who doesn't really use Fusion, this is not interesting at all. But anyways, I made this change. When I'm done, I click OK. It's going to freeform change that surface into whatever. And that's quite powerful, because now I don't have to move into a completely new environment inside of Fusion just to make that change. It's pretty cool. Anyways, when I'm done, I can just say finish base feature. I jump out of this, so everything from this now, if I move it and I make a fillet or whatever, it's going to record that as a feature, and it's going to be added on top of that one. So this is the Fusion part of Fusion, that it merges all of these areas together. I have 7 minutes left, so I'm going to steal 2 of them and just show a quick freeform. Then we have moved part of some quite wide parts of Fusion. And then we can end off with some Q&A. So freeform, I'm going to make something organic. I'm going to make a vase. I'm going to make something that's freeform. Then I move into the freeform area. It's all the purple, strong purple stuff is freeform. Then I can say take a ball, for example, place it here. How big should it be? How many surfaces how many faces should it be on each side? I just take a standard now. And now I can start with the edit command. The edit command is the base command that we use in this area. So if I now right click and say edit form on that point, I can move that point and do whatever I want. I can do the same thing on the surface. I can scale it up. I can move it. I can rotate it. So you don't have parameters per se in here, but you can still take that surface and move it up 5 millimeters if you want. I can take, let's say, this edge here, and then I can scale it in to make a pinch effect. If you want more detail, we just add more surfaces and so forth. I mean, now we made something. That's awesome. As soon as I say finish freeform, it's going to convert this into a solid model. And that's pretty cool because it's a T-spline, we call it that, but it's basically a subdivision model. So as soon as we're done, we say finish, it converts it into a solid. And now I can go on and do other stuff with it. I can say, create a new plane. It's going to be based off that plane. It's going to be in the middle or there, all right? We have a work plane. I can say, split this body from this work plane. And now we have two bodies that we can work with. We can add a fillet here, we can make it hollow, so we can 3D print it or whatever. When we've done all of this and we say, okay, we need to change the form of this a little, we can go back and we can try to actually do that in the freeform model. So it continues to remember the base of this. Now I'm going to see if I take these and I scale it, move it in that way. Looks pretty good. As soon as I say finish freeform, it's going to remember all of the features that I added from this. So it's a freeform model that we can move exactly, and we can have parametrical features on this. It makes it really powerful. I can end off the last minutes with some, it's free for makers and hobbyists and startups. People ask me, when do I pay for it? As soon as you make money of the things you do in Fusion, I think you should pay for it. $300 a year for the first version. It should be fine if you have revenue from this. Otherwise, it's free. And this is the reason why I think it's become so good during the years, that the community is driving this. If the community says we need sheet metal, all right. Apparently, sheet metal is important to you guys, so then we add sheet metal into this so you can do your sheet metal design. So it's all of the features, everything that we do in here is almost exclusively driven from the user base. So if you want to be a part of Fusion 360 and be a part of changing it and say what you want from it, go into forums.fusion360.com or just Google Fusion ID. It's called Fusion. I have to check this. Fusion Idea Center. Fusion ID Station heter det. Sorry, so a lot of names. Fusion ID Station. This is the voting system. So you go in here and you say, I want this. And then people can say, oh, that's a good idea. And they give it a thumb up, a kudos, we call it, a like, whatever. And then it becomes higher and higher up the list. And with that you can, where is it? Then we made the design. Okay, so you can give it a vote, and the more votes it gets, the higher up it is. And our development is going to look at that. So if you go in and look at the top voted, you can get a hint of what we're working on for Fusion. It's not that hard, and we have an open roadmap as well. So sheet metal development implemented, all right, so we can vote for it, but locally stored all files, okay, we're working on that. Gear generator, and so if you want to be a part of this, go in here and just give it a vote. If you don't want to type something in your original ID, just scroll through the top ones and give it a vote. It's going to be a high, the chances are quite high that it gets included in Fusion. So I understand it was from nothing to everything in like an hour. Me and Rick are going to be here all week, all weekend. So come by the Autodesk booth and talk to us. We are happy to answer Fusion questions. Thank you.
Thank you. Thank you.